Okay, hey guys. I found out that the last stream for the You've Got Mail Part 1 project for our Solidworks class, I left my face up over the entire Solidworks window the entire time, which means the demo was relatively useless. So this time, I'm going to make sure to scale my face down, put it in the corner, and we're going to re-record this demo from Tuesday the 21st's class. So hopefully you guys will have a chance to watch this and use it as reference just in time for you to do your sketch modeling in a SolidWorks assembly. So let's get started with this stuff. I'm just going to take a quick look. So once again, this is for Design 3400-01. Our 8th lesson and the first part of our You've Got Mail project. This project is all about teaching you guys some of the basics of how to work within a SolidWorks assembly file by designing a mailbox comprised of laser cut 2D parts. Yeah, it's pretty cool. So the material that we're going to be using for laser cutting, which is a process, again, just to go back over it really quick, a process where a laser will move in 2 different axes to cut through a material in whatever shape we want. The thickness of the material we're going to be using is 1/4 inch, or as you'll see in SolidWorks, there's a nice little shortcut to translate that into millimeters, which is what we design in. And your homework assignment for this part of this assignment is to create dimensionally accurate mailbox models, sketch models, to be used really as a reference. We're going to tweak those models and then continue to design them for our laser cut mailbox final assemblies. So let's see, I'm going to switch back over to the stream really quick. And I believe the live chat thing, maybe the live chat thing isn't really working right now. That's all right. If you do have a question, I'll pull up my email. Feel free to shoot me an email, and I'll try and check that at least once during the middle of our demo here today. Hopefully I can be done by about 1. I've got about an hour on my lunch break, and then I'll check again toward the end of the demo just to make sure I'm addressing any questions you guys might have. So, all right, let's just jump right into it. During class on Thursday, I sort of went over the basics of assemblies by building this really basic sketch model of a mailbox that kind of looks like a house. I'm going to start completely over from scratch so that you guys have a chance to see everything all over again. So I'm going to go back into the folder where I saved everything and just delete it, and we're going to start back over. All right, so I've opened up SolidWorks 2016. I'm going to start a brand new file, and although, yes, we are going to eventually create an assembly or a collection of parts in a brand new file type that we haven't really dealt with yet, I'm going to start this assembly actually as a part. So, yep, not an assembly file. I'm going to start as a part, say OK. And hopefully at this point you guys have all had a chance to sketch out a bunch of your ideas for a mailbox, and hopefully you've designed it in such a way that each of the components of your mailbox is going to be like a flat component that we can assemble together, glue together, eventually to create a 3D mailbox. So usually the way I like to start in a part file is choose maybe the base of my mailbox, and I'll start with a very simple part for my base. So I'm just going to choose the top plane right now. Doesn't really matter. And create a sketch, and I'm going to make the base of my mailbox. All right. And I'm just going to add some dimensions that are dimensionally close. Again, this is a mailbox, so I'm keeping in mind about the size of the letters or small packages I imagine our users of this mailbox are going to be depositing or withdrawing. So let's just say this is going to be about I don't know, 120 millimeters wide and about 225 millimeters deep. We can always adjust those later. Notice my lines are all nice and black as opposed to blue. It means I'm all completely dimensioned. Nothing can move around on its own. And I'm going to go ahead and extrude this to the thickness of my material. Everything I design for this mailbox is going to be the thickness of the material I'm cutting, which I mentioned before is 0.25 inches. Now if I type in 0.25 IN, hit enter, Solidworks, good Solidworks, is smart enough to convert that over to millimeters because I'm working in a metric environment, and that's great. So 6.35 millimeters is sort of the magic number. You'll see that pop up time and time again. I'm going to go ahead and say OK, and there's the base of my mailbox. Great. I usually like to look at it with perspective on. There's this little perspective button. Again, if you don't have any of these buttons in your menus, we've covered this a couple times, but you can always customize what's in your menus by opening up the customized menu, searching for the commands, and then dragging them in wherever you want them. You can also search up here for commands. As I think Dexter was mentioning before, you can say search for a command, say like perspective. There it is, and I could drag this out and put it on my toolbar. Side note. Okay, so I've got one component, and first thing, now that it's built, I'm going to save it just to make sure things don't go crazy. I'm going to actually start a brand new folder for this. All of the parts and the assembly file that you're creating should be in their own folder, and that's going to help transferring your files or moving things around a lot easier in the future. So let's see, this is, I actually have a folder for this already, and usually when I know I'm working with an assembly, I'll start by actually naming this, like this is a mailbox base part. I'll put the word part in the file name. It's easier for me to remember what parts are parts, what parts are assembly files, and you'll see as we build all these out why that's important. All right, so save, there we go. Okay, I have one part. Now I can get started on my assembly. There are a couple ways to bring a part into an assembly file. The first way I'm going to show you is by going up here to the, if you kind of move your mouse over to this little caret, go to the file menu, you can say make assembly from part. So I'm going to click that. That's actually going to create a brand new file, which is a completely different file type called an assembly. You'll see up at top here, SM1 is the default name. And it's going to bring up this little menu that says begin your assembly with that open document. And all I need to do is say green check mark. And SolidWorks will bring the part I was just working on into my assembly file. It looks almost identical to what I had just built. Actually, this geometry is identical. What's different, there are a couple things. One, you'll notice I have a brand new tab up here in my menus, which is the assembly tab, and it has a whole bunch of special things that we can do in an assembly we can't really do in a part. We'll get into that. You'll also notice that in my feature tree, I have the normal, my planes, history, sensors, origin, but instead of features, I have the entire part. There we go, mailbox base part 1 is sitting over here in my feature tree, and it has its own set of all of the things that you would find in a part file over here. You'll also notice that there's a mates area, and we'll get into mates pretty soon too. So, okay, I've started my assembly. I'm going to go ahead and save that as well. I like to name assemblies, like assembly, and this is my mailbox. And I'll say, okay, it's in the same folder that my other parts will be saved in, and we'll note that it's an assembly type. It's not a part type. So I'll say save. Wonderful. Okay, let's start a new part, a brand new part, and I'm going to build one of the sides of my mailbox. So here we go. Oops, show that. Just hide that again. Start a sketch. And the side of my mailbox. Well, I'm going to make it a rectangle. And let's say I would like it to be 115 millimeters tall. Maybe a little taller than that. I can always change it. And how wide? Well, or I guess how deep, how long should this mailbox be? Probably I want it to be about the same length as the base of my mailbox. And if I don't remember, what was it, like 225? I'm going to put that in. Hit escape to get out of my dimensioning tool. This is the first like little pro tip. If you have multiple part files and assembly files open, you can hold the control button down and then tap tab to bring up a list of all of the things that are open right now in SolidWorks. And you can use your mouse to click one, or you can press tab, press tab, press tab to sort of cycle through. I'm going to go back to my mailbox base. Remember, we built this first, and take a look at the dimensions and just double check. Yeah, 225. Okay. Now I'm going to go back, control tab to get back over to my part. And make sure that it matches up. Yep, looks good. We're going to extrude this 6.35 millimeters. That's the thickness of our material. I'm going to say green check mark. Okay. I'm going to save this part. Control S as my mailbox side part. Okay, cool. Now, last time we went up here and said File, Make Assembly from Part. Well, we already have an assembly file started, so I don't want to use this option. Instead, I'm going to go back to my assembly. The other way that you can do this is, actually these buttons are kind of neat too. Each of the files that you have open in SolidWorks has its own window. It can get kind of confusing. You can maximize, minimize. Really, you can minimize a bunch of parts until you find the one that you want. Mailbox based part. No, I'm looking for the assembly. Aha, assembly mailbox. I'll maximize that guy. And there we're looking at our base part. I want to bring in my side part into this assembly. So one of the other ways that you can bring a part into an assembly is in one of the tabs up here is called Assembly. In the Assembly tab, you can insert a component. So I'm going to click that. And which part or assembly, yes, you can insert an assembly into an assembly. Which part do I want to insert? I want to insert my side part. And I could say green check mark, but for a reason I don't want to talk about at the moment, I'm not going to do that. Instead, I'm going to use my mouse and just click somewhere out into my build area, place this component. And you'll notice, well, it's not oriented correctly. This is where our first lesson about assemblies, I guess one of the most important tools in an assembly we're going to get into right now is called mate. So a mate is a constraint, kind of like the constraints that you can add inside a sketch to make two lines perpendicular or parallel or coincident. Within an assembly, we can use a special kind of constraint called a mate to attach entire parts to one another in a specific way. So, and then there are a couple ways we can do this. The first one I'm going to show you is I open the mate menu. Let me go back and do that. So click mate. I'm going to use two faces. I'm going to mate them together, make them flush. So I'm going to click one face, and notice I click it and it kind of disappears and also highlights it. So I'm going to attach that face to this face. And you'll see that SolidWorks kind of reorients the part in the way that I would like it to be mated. And it's a coincident mate. By default, SolidWorks will kind of pick one that it thinks you want to use. You can hit green check mark on the little special menu that pops up, or you can hit green check mark up here. And then this menu should stay open to let you add other mates. If it doesn't, just go back into mate, it'll reopen. All right, so that's one mate. Now notice I can still drag this part around, but no matter where I drag it, it's coincident. My face here that I selected is touching the face here that I selected. All right, let's make this face and this face, coincident also. See what happened there? They're all lined up, and again, green check mark. I can still move this thing around, and I think I want this face and this face to be coincident also. Just as a point of like an interesting other thing that you can do, let's say I wanted to leave a little space. Maybe I want my side to hang down a couple millimeters to leave the base, I guess, not flush. Once I pick two faces, another mate that I can add is a distance mate, as opposed to a coincident mate, and it will let me add a dimension, say 5 millimeters, that those two parts, green check mark, maintain. So this part, if I try to drag it around, still is fully defined. It can't be moved, but it has that distance inside here if I want to keep that distance. Okay, so there we go. I have two parts, my side and my base. In my assembly file, I'm going to say green check mark, all done with mates for now, and Control S, save my assembly. Great. All right. Next thing I'm going to do is build the back of my box here. And just like the other demo, I'm going to make it a different shape, kind of make it look like a house. So let's start yet another part file. I'm going to make a sketch. I want this to look something like a box with a roof on top of it. Let's see here. Maybe to make this, make these constrained vertically so that it always stays in the center. It's kind of neat. How wide should this be? Well, how wide was our base part? I think it was 115. And I think I wanted to cover both material thicknesses, and you'll see what I mean here. I'm going to add 6.35 twice. And I can actually type in plus 6.35 twice, and it will give me a new width. You'll see why I did that when I import this part in. I want this to be the same height as my other one, which I think was like 150 maybe. I can always go check this. I want my roof to be maybe another like 75 millimeters tall. Again, this is all based on whatever design it is that you've sketched out that you're trying to mock up. And it looks like all my lines are black. I am going to get rid of this line in between here for my extrusion with the trim tool. Power trim is my favorite version. I'm going to click and hold, and you'll see I'm like dragging this trim line and cut that out. Oh, it looks like it got rid of one of these dimensions. Oh, and it got rid of my constraint too because I deleted the line. The other thing I could do, I'm going to undo Control Z a couple times here. If I don't want this line to interfere with the extrusion I'm going to do, I can change it to construction geometry with this little shortcut, or over in the menu here say this line is for construction. It will turn it into a dotted line, and now you can see I have one continuous shape that I should be able to extrude, once again 6.35 millimeters, to make my house shape. All right, let's double check those dimensions really quick. So I'm going to go back to my, I guess my side part, click on my boss here, the dimensions should pop up. It's 225 long, 150 tall. I'm going to Control Tab back to my part here, 150 tall, and oh, I guess the length isn't important, 150 tall. Is that right? I already forget. Yeah, 150, okay. Cool, so that part's ready. I'm gonna Control Save, Control S, save that. Mailbox, front part, save. Control Tab over to my assembly. Notice it says assembly, mailbox. Here it is, and I'm going to import a part once again using my insert components. Mailbox front part, there's the part. I'm just going to click somewhere out here to put it where I think it should go. And I'm going to use mates again to get this lined up. All right, so let's say I want this face to mate up with this face, and then green check mark. I want this face to mate up with this face, green check mark, and I want this face to mate up with this face, green check mark. All right, now it looks like I might have had not quite the right dimension on the width of this part. You can see, oh, no, I don't want to start another mate here. You can see that I wanted the edge of my face here to be lined up with the edge of the side part. Hopefully, if I added another side part to the other side of my box, this edge would be flush with the outside of the box too. It doesn't look like that would be the case. So there are a couple ways that we can change this. Before I get into that, so I make sure I have the right dimension, I'm going to show you another fun tool in assemblies. So, and this is something based on a question I think Tessa asked during class. She asked, can I bring multiple versions, multiple instances of a part into an assembly? And the answer is yeah, absolutely. Let's say I want another side for my mailbox here. I can insert a component, choose mailbox side part again, just click somewhere out here, and here we go. I have a completely separate instance of my side part, which then I can mate. So I want that, coincident with that. Now notice that actually flipped it sort of the wrong way. There is a flip mate alignment button that will let you switch things around if the mate that you're trying to add ends up being sort of the opposite. I want that face coincident with that face, green check mark, and I would like this face to be coincident to that face, green check mark. Okay, now you can see what I'm talking about here. I wanted this edge to sort of cover up the face of this thing right here. So green check mark out. Let's check some more dimensions. All right. Now, I know I've been doing a lot of like control tabbing to get to other parts. Another way that you can go back and see a part or edit a part is click it in the assembly and then use this little open part icon that pops up, and it will bring you right to that part file. Let's see. So this is 120 millimeters. I think I typed in 115. So 120 millimeters is the width of my base. And if I control tab over to my mailbox front part, I think I mistakenly said this was 115 plus 6.35 plus 6.35. Remember, I was trying to add extra material to cover up two material thicknesses. I know now it's 120 millimeters plus 6.35 plus 6.35. Say OK. Save this part, and then go back to my assembly. Now, when you update a part that is also in an assembly, chances are this little warning is going to come up that basically asks you if you want to update the assembly to match the changes you made in the part file. And I said yes. Okay, and now you notice that extra dimension updated everything, and the back half of my, I guess the front of my mailbox now covers up all the edges. That's what I wanted. Okay, now I could bring another instance of this part in to, actually, you know what, why don't we do that really quick? So I'm going to save my assembly. Again, with SolidWorks, just save everything all the time. SolidWorks likes to crash at just the right moment. I'm going to insert a component. We're going to add another front part. Just drop it somewhere in my assembly. Use mates to make this face flush with this face, green check mark. This edge flush with that edge, green check mark. And the bottom here flush with the bottom here, green check mark. Okay. I've got a box, starting to look like a house. I guess we're getting close to what I want this thing to look like. Green check mark. I'm going to save one more time. All these mates that we've been adding, have been populating in this mate list over here in the feature tree in your assembly file. This is important because sometimes when you edit a part or you change a part or you delete a part, things will blow up, you know, just like in a part file. If you change something, features will turn red and give you an error. A lot of times in an assembly, what can go wrong when you change a part is mates, like other relations, they'll stop working. So you can go back into any one of these mates and edit it, delete and reselect faces, or just get rid of the mate altogether. Anyway, that's where that lives, and we'll see if we can't get something to fail so I can show you kind of how to troubleshoot it and fix it. Okay, so far we have built a few parts as independent part files and brought them into an assembly. And now I'm going to show you a different kind of way to create a part for an assembly. And this, I guess, has its advantages and disadvantages too. So another way that you can add a part to an assembly is creating it inside the assembly from the get-go. So under the Insert Components feature in your Assembly tab, if you hit the little caret, in addition to Insert Components, you can also say Create a New Part. So I'm going to create a new part, and you'll notice, maybe, that by my mouse there's this little green check mark that appears. Solidworks wants me to click somewhere in this viewport to start my new part. Just know that that happens, and you have to do it when you create a new part inside of an assembly. You'll see that a brand new part appears in my feature tree, and it has a default name, Part 4, Assembly, Mailbox. It just added a new part, but there's no geometry in that part yet. And if I click this part, unlike when I click one of these other parts, nothing actually is highlighted because there's nothing in that part yet. In order to add geometry into that part, there are a couple ways I can do it. I can open that part, which is a little abstract. What I'd like you guys to do is to edit the part. So I'm going to edit this part in the assembly. It's a part file inside an assembly file that doesn't have geometry. We're going to create some geometry. So when I edit the part, it will ghost out all of the other parts in my assembly and give me the same set of commands like sketch tools and features, direct editing that I have in a part file normally, only I can use these other parts as reference. So what I want to build right now is one of the roof areas for this mailbox thing that I'm creating. So just like any other part file, I can sketch, and I'm going to actually pick one of these faces on the top of my roof to create a sketch. Say sketch. Okay, and I'm going to make a box that is, actually we're going to make a box that's a little bit bigger than the top of this mailbox. I can actually add relations, like say between this line and the top edge of this part. Zoom in a little bit. I'm going to make them collinear. And it's actually adding a relation to a part that's outside of the part file that I'm editing. Again, this is kind of abstract if it's not quite making sense in your head right now about how this is all happening. Just know that we're creating a part in a slightly different way than you would if you're creating a part outside of an assembly file. All right, let's add some dimensions to this sketch here. Like, let's say I want the distance between the outer edge of my mailbox to the outer edge of my roof to be, say, like 30 millimeters. I can still use this like normal to button to like square up and dimension things this way too. Okay, I want that to be the same, 30 millimeters. And I want my roof to be, let's say, 120 millimeters long. And if I rotate this, you can see I'm kind of adding a little bit of an overhang to the edge of my house mailbox thing. Okay, that sketch, everything is black, so I'm happy with that. Go back to the Features tab. Now notice one extra set of things is happening when I'm editing a part inside an assembly, I have this extra set of things on every single tab that say like edit component, no external references, assembly transparency, this kind of thing. We're going to talk about this in a second. Ignore these for now. All of your tools that you're familiar with will still be in these tabs. They're just in a slightly different location. So anyway, create an extruded feature. How thick? One material thickness, again, 6.35 millimeters or 0.25 inches. It should convert for you. I'm going to say OK. Now normally when we create a feature in a part file, we'll have to pay attention to whether or not we want that part to merge with another part. Still applies here, except SolidWorks knows not to mate this part, anything we create as a part of the part that we're editing, to anything that's outside the part file in the assembly file. This will never merge with any of these. Okay, so there's my roof, or part of my roof. And that looks about the way I want it to. So I'm going to, there's one layer that I'm going to try and get out of to get back to editing things in my assembly. And you'll notice over here, the same place where you would exit a sketch, or up here where it says edit component, if I click this, it will bring me back out of the part file that I was editing inside the assembly file. And now we're back into the assembly file itself. And you can see that all of my parts are unghosted, and they look the way that you guys are used to seeing. All right, let me save really quick. Ooh, an extra menu popped up. Following models referenced in this document have been modified. They will be saved when the document is saved. And it's talking about this random part that we created that we haven't given a name, our roof part right here. It hasn't been saved at all. So I'm just going to go ahead and say save all. And SolidWorks will ask me whether I want to save it inside the assembly, like as a part of the assembly file, or save it externally as its own part file. For now, probably the easiest thing for you guys to do is just say okay, save it inside the assembly, and and leave it at that. I'm gonna save one more time just to make sure all of those options happened. If this menu ever pops up about rebuilding your document before saving, go ahead and rebuild. Okay, so I have a roof. I've got front twice, front and back, two sides, a bottom, and part of a roof. Let's create the other side of this roof really quick. And let's see, is there a third way that maybe I want to do this? Well, that's interesting. Actually, as I'm looking at my part file from this direction, and I'll turn perspective off, notice the angle of my roof here on this part must not be 90 degrees, unlike the material here. And if I want the next part of my roof to line up perfectly, I could go back and edit this part. So let's do that really quick. All right, once again, let's say I have a part inside an assembly that I want to change something about. There are two ways to do it. I could click this part, say open it, it will open the part file back up, and I can go back into my sketches and change things. That's one way to do things. The other way that you can do things, let's go back to the assembly, is click the part, and instead of opening it, I can just go right into edit it. Where is it? Edit part. I could click it here, or I could click over here and say edit part. Same kind of crazy thing happens, right? All of the parts I'm not editing get ghosted out, and I can open the feature tree for just this part inside my assembly file and mess around with things. For example, let's say I want to change this sketch. I'm going to edit the sketch. Let's square up to it and change this so that it's a right angle. All right. Now I have a feeling if I try and click these two lines in my sketch and say make them perpendicular, ooh, things are going to get angry. And I have a feeling, I know why, it's probably because in order for those two lines to be perpendicular, this point is going to have to move, either up or down, probably down. So right now my dimension, or my sketch is over constrained. SolidWorks can't figure out which things it should follow to create the sketch. I'm going to click this dimension here and delete it. And it looks like that's all it took to fix my problem here. Now if I went back in to add a dimension between this point and this line just to see how tall it was, it's going to ask me if I want to leave it driving, meaning have SolidWorks treat it like it's trying to tell the sketch exactly how tall to be. Once again, you'll see everything starts to go yellow or red, which means it's unsolvable. I could also change it and say, make this dimension driven. And I'll show you what that means really quick. Basically, it leaves this dimension grayed out. This dimension is not actually controlling my geometry. It's just sort of there as an indication of how tall this box is. That's kind of a wormhole side thing, but I figured we could talk about it because it was something I wanted to change. All right, I'm going to get out of my sketch. Notice the part updated. And if I get out of the part, notice that the assembly updated too. The mate that we added between my roof part and, oh, I guess we didn't add any mates because we built it as a part of, like a part inside an assembly. Everything updated and we're okay. That's cool. And it looks like everything is all squared up. So I can create one more side of my roof. Great. So let's do that again. I'm going to create a new part inside my assembly. And again, I have to just click somewhere out here to say, yes, I wanted to create that part. The part has no geometry in it. In order to add geometry, I have to open the part file or edit it. Let's edit that part I just created. To make a sketch, I'm going to have to pick a plane to sketch on. I'm going to sketch on this side of the roof. Sketch. We're going to make a box. And notice when I created my box, I picked the corner, the top of my roof part up here. I'm also going to say constrain this line so that it's even with my roof. So I shift click to the edge of my roof file. And then how long do I want this to be? Now I'm thinking I could probably say I want this line to be even with this line, collinear. Oh, no, didn't work. Let me undo that. That did not work the way I was expecting. Oh, because, yeah, I see what's going on. All right. Instead, maybe I can say make this line. You know what? I might just have to dimension it. How long should this be? I already forget. Like 150. No, that looks too long. You know what? I'll leave it as 150 and we can go check. I'll get out of the sketch, go to my feature, say extrude, 6.35 millimeters. Okay, there's my roof. It's a little too long on that one side. There are a couple ways I could adjust it. One would be to go out of this part, click on the part that I want to measure. We can edit that part, open up its feature tree, click on the feature that I made, and see if I can 120 millimeters. Okay. Now, that's one way I could do it. I'm going to get back out of that part, click the part I want to edit, say edit the part, close the old feature tree, open the feature tree of the part that I'm now editing, click my feature, and say, oh, it shouldn't be 150, it should be 120 plus this extra material, because you can see this part's like overlapping the thickness of the material here, plus 6.35, okay. Yeah, that looks even. Get out of the part. I'm just going to close this up. Yeah, that looks pretty even to me. I'm going to hit save. Once again, we created a new part inside our assembly. Yes, we want to save that too. Yes, let's save it internally, and that's fine. Let's turn on some perspective, and there we go. So, I've covered a few different things. with creating parts, creating an assembly, importing parts into an assembly, placing parts inside an assembly with mates, creating parts inside an assembly and using references to other parts inside the assembly to make sure everything lines up. This is the kind of stuff, basically this is the level of sketch model you guys should be able to accomplish for this part of the assignment. Notice the joinery, like how these edges come together, is all very simple. We're basically mocking up a butt joint. It's the type of joint where if we added some glue in between this part and this box could exist in real life. Now, real laser cut parts have a lot of other types of joints that we can add. Mortise and tenon, finger joints, and we'll go over that here in a second. But for now, wow, we only have 20 minutes left. I'm going to go to my email really quick and see if there aren't any questions from you guys, if there's anyone watching this live. Let's see. There's someone watching live. It might just be me. Let's refresh. Nope, doesn't look like anyone's here. So we're just going to keep cruising along. Okay, SolidWorks. Man, which one of these? The assembly. Okay, so there's my part. There are a couple other things I wanted to show you really quick. One of them, so I'm going to close all of this stuff out, all of my part files, my assembly. I'm going to go back over to one of the other demos and open up a new assembly. This is something I created before class last time. This assembly has some more complex joinery used to hold these parts together. And if we go to Carmen, you'll notice I posted a couple helpful links inside You've Got Mail Part 1. One of them goes to Instructables, which has a great little, I don't know, intro to things that you can make with laser cut parts. And if we scroll down a little ways, one of the things it talks about is different types of joinery. Here we go, finger joints, mortise and tenon joints, a slot joint. There are a lot of ways that laser cut parts can be joined together. And that kind of detail, I don't think you guys need to include yet in your sketch models, the two that you're making over the weekend. But it's something we're going to talk about further during Tuesday's class. So just know that you can do it, and it's something, again, all of these parts, if I open one of these parts up, they were created independently as part files and then brought into an assembly file. And the great part about an assembly file is you can see by using mates to attach things together whether or not your part has a chance of existing in real life. I was able to check and make sure that all of my joints lined up. And now I know with at least some degree of certainty that when I laser cut these parts out, my mailbox house thing should work. It should actually come together. All right, so along those lines, the other reference that I wanted to talk about today was also in Carmen. It's a website called makercase.com. Now, I'm sure all of you are capable of figuring out how finger joints might come together to create a part in SolidWorks, but it's going to take some guessing and checking and maybe some sketching to figure out how everything works. There are a few websites, including makercase.com, that will generate finger slot geometry for you for a box of whatever dimensions you want. In this case, well, let's switch to millimeters. Let's say we have what was our box? Like 120 by 150 by 2 something, 230. I don't really remember. Inside dimensions. This website will actually create a 2D sketch for you with all of the joints that you need to create your material. I mean, create the sketches to make your box and actually add joints. 6.35 material millimeters thick. Here's all of our joints. So this brings me to the next thing I wanted to show you, which is even if this particular tool isn't super helpful for you and your particular designs, it might be worth creating a box using some of this 2D geometry just to wrap your head around how these joints actually come together with a sketch, and more importantly, how we can use a 2D vector drawing generated from an online tool or even in a program like Adobe Illustrator and bring it into Solidworks to create a sketch that we can use to create geometry. So let's do this. I'm going to generate my laser cutter plans from this website and just make sure, let's see, it's vector stuff. These are all like laser tool specific things that we don't have to worry about. I'm going to download these plans as an SVG document. SVG is just a type of vector format. Let's go to MOC, and this is case plans version 2 because I did this once in class. I'm going to save them. Let's go to those plans, and now there are a couple different file formats that SolidWorks likes, vector file formats, and SVG I don't believe is one of them. So we're going to open those plans up in Adobe Illustrator. Hopefully you guys have access to that. And take a look. So I'm going to zoom out a little bit. Now I'm going to delete all of these different parts except for one because I'm creating one part at a time in SolidWorks. And I'm going to save, or is it export? I'm going to export this geometry, this single line, export it as a format that SolidWorks likes. SolidWorks likes DWGs and it likes DXFs. I still am not super, I don't really know the reason why you would pick one over the other. Both of them will work. I'm going to go with DXF because my wife Kayla mentioned that we should use a DXF in class the other day. Something to do with keeping dimensions. And anyway, let's just go with DXF. I'm going to say export. Make sure that my units are millimeters and that the scale is 1 millimeter equals 1 unit of whatever. The rest of this is okay by default, and I'm gonna, let's say, Control Z and make sure I have all of my parts still in this part file. Now if I go back to my folder, let's see, I do have a case plans version 2 DXF file, and I might even name this like this is my side part, because I'm probably going to have to export each and every one of these as its own DXF file. I'm not going to do that right now. I'll just show you how to do it once. We're going to go to SolidWorks and create a brand new file, part, okay? And this is how you import a DXF into SolidWorks to use. I'm going to pick a plane and go to Insert. Now, I have to, if I go up to Insert without choosing a plane, wow, actually it is open. You want to pick a plane first. So I'm going to say front plane, that's where I want to insert my DXF file. I'm going to find it somewhere, wherever I saved it. Say open. And you're going to get a whole bunch of menu options. First one, you almost never have to change. Yes, I'm importing it as a 2D sketch. The next thing it's going to ask you is the units of your imported data. Just remember that we wanted this in millimeters. These other options you don't really have to mess with. Next, more options about merging points and adjusting things in your geometry. Don't have to worry about any of that stuff, and finish. This warning always comes up, and I always say yes. And if I zoom out, yeah, notice that it didn't look like anything happened. I kind of zoomed out. Here are all the lines from my Illustrator file. These ones right here. And they're in SolidWorks. Hooray! Now, This is one very important thing I want you guys to try and remember. When you import lines as DXF into a SolidWorks sketch, usually they're all blue. And if I click and drag something, even if it's accidentally, it's going to mess up the orientation of these lines. Let me undo that with a Control-Z. One way to prevent that from happening is to click and drag, select everything in that imported sketch, and in a secret little menu that pops up, there's an option, an icon that says Make Block. That's what I want you to do. I want you to make something called a block with all of those lines. This menu pops up about Make Block. It has all of the lines inside this sketch selected, and I want you to hit green check mark. Let me click off of there. Notice all of those lines turned gray. And when I click and drag to move this around, they all stay oriented, related to one another in exactly the way that I wanted them to from my import sketch. Another great thing about making a block or a group of sketch items is if I click anywhere on this sketch, this block, a block menu will come up that will allow me to do things like rotate it or scale it. Let's say I only wanted this half the size. And it maintains the relationship between all of those parts, all of those sketch entities, I guess. Okay, so I've made a block after importing a sketch as a DXF, and I can use this just like any other sketch. In this case, I want to extrude it 6.35 millimeters, say OK, and there's the part that I can use in an assembly. Now, once I've exported each and every single one of these as its own part, I can bring them together, assemble them, and make sure the box fits. I'm not going to do that here just because I don't really have time, but I'm sure you guys can figure that out based on everything else we've covered so far in this lesson. So let me just save this in my, I think this was part C stuff. Yeah, sure. Box, I'll just call it like imported geometry box side, something descriptive. Okay, so I think that sort of ends my demo for today. I'm going to check the email one more time to make sure there aren't any questions coming in via email, but we've covered a whole bunch of great stuff. Namely, we have talked about creating independent part files and assembling them together in an assembly file in SolidWorks. Doing so using mates, creating files, part files within an assembly, and using other parts as reference to make sure everything lines up. We've covered how to create 2D geometry outside SolidWorks, either from a website or using Adobe Illustrator, and then from inside Illustrator, exporting it as a file format, DXF, that SolidWorks likes, importing it, and then using it to create a sketch inside SolidWorks to make things. That's a really powerful tool. Actually, all of these are very powerful, and I'm sure we're going to keep using assemblies and mates and imported 2D vector geometry throughout the rest of our course. And hopefully, this live stream is going to work out just fine. I don't think my face was big the entire time. So, all right. Switch back over to mail really quick. Make sure there aren't questions. Doesn't look like we have any new questions. So that's it for my demo today. And I guess I will see you guys in class tomorrow. Good luck.